So this is code for 2-point boundary value problem loop for an unknown trajectory for a binocular case. And so to be completely clear, this code does not work. However, it does successfully make a loop within COMSOL, which is mostly why I'm recording this. Also, just if we ever want to come back to this, but it does successfully create a COMSOL loop for solving problems. So I just thought I would record it in case we ever want to make another COMSOL loop. So the important thing about making a COMSOL loop within MATLAB is that all of the model all of the features that we want need to be created outside of the loop. So we're going to set up COMSOL. This I'm just randomly generating a model name because it doesn't let you repeat a model name, and I didn't want to manually input a model name. So this isn't super important, but yeah, it's just creating random model name every time you run it. Okay, so all of these things are the components that we want. So pretty much, yeah, we have to even attach our solver here, which don't be tricked because at first I thought we wouldn't need that, but we do. Yeah, so these are all just setting up the COMSOL file. And so even if things are going to be changing, that's one thing that's important. So for example, for this loop, this is the 2-point boundary value problem loop. So again, we're going to be solving a 2-point boundary value problem at each iteration of the loop. So from time t to time t plus n times dt, where n is our prediction horizon. And so in that case, the interval is changing every time we do the loop. And so even then, we still need to create our interval outside of the loop. And what we're going to do inside of the loop is just change the values that we assign to that interval. And so that's just the same for all of these. Again, even though we're going to be changing our boundary conditions throughout, we just need to create them first here. So this is all just importing our function files because they're really big. And then this is where the loop starts. So we're just going to declare simulation parameters. Again, this dt or n times dt is where it's going to be solving from. That's going to be the size of our interval. So here we have some true trajectories. Again, we're initializing state variables. Sorry. This is another function for linear extrapolation. And yeah, if you want more information on this, check out my 2-point boundary value problem Binocular MATLAB code. There's a video. All right, so then here's the COMSOL loop. So basically, again, we're just looping through time. I'm just timing it. So what's happening here is that we're just setting the time to be the current time. This is going to be how far into the future we're predicting. And then this is where we're just going to predict the function that we saw up above. So now this is all the COMSOL stuff. So basically here, I'm just putting in the initial and final conditions for the state variables. And so those need to be in character form. And so I'm turning the value z1, which is just a stored value in the z vector, into a string, and then into characters. And then same for these final ones, but with the predicted z values. And then, sorry, ignore this. Okay. So then with the initial guesses, we've had a bit of trouble. So honestly, don't think too hard about this right now, but we have a couple of initial guesses, and I've just stuck with Ben's initial guess, which has been very carefully derived, thank you, Ben, in order to fit all the initial conditions, including the derivatives. And for the co-states, we're just guessing 0 to start. So then we're just going to set the variable phi r equal to this. And then here we're going to set the interval. So again, these components have to already have been declared outside of the loop. Here we just set the values. So we're setting the start of the interval to be time t and the final to be t plus dt future, which is just n times dt. All right, and then over here, these are just the components of the PDE. This is selecting where our boundary conditions are going to be. So our first one is going to be a Dirichlet boundary condition, and our second point is going to be the flux boundary condition. And then over here, we're setting the PDE parameters. So most of these are just going to be matrices of 0. But here we're also setting the functions f. And then beta is going to be the identity matrix. So I'm setting it to an identity matrix, and then this smashes it into a vector, which is what the state that it needs to be in for COMSOL. And then here, again, we're setting our initial guesses. So those are those initial guesses that we declared up here. And those guesses, they take in these C coefficients. Those are the ones that Ben derived, and those are going to be declared right down here. They're going to be reevaluated for each interval, and so they're going to be reset each time. And these are just the boundary conditions. Here's the initial conditions again. Yep. And then just general parameters within COMSOL are being set here. A and B are the separation vector. And then all we have to do is run the solution. So, which again has to have been already declared as a component outside of the loop, but here we just run it. This allows us to store the solution for each of the values. And then down here we can plot those solutions that we got. We're going to append those onto the matrix, and then we can plot them down here. So that's how this code works. Again, works is sort of a general term. It does run a loop, but it seems to run into some errors around solving. Usually it'll solve a couple of time steps, and then it'll have an error. So somewhere in here, there's an underlying error, but I just wanted to record this video because it shows how to set up a COMSOL loop, which I think could be a valuable thing to know. So that's it. Bye.